The next concept we're going to cover in this lesson is isosceles triangles. These are a special type of triangle that are very, very useful, and you've probably learned about them before. So first, let's just talk about what an isosceles triangle is, and then we'll learn a theorem about them. So the definition of an isosceles triangle is a triangle with at least two congruent sides. So if you have two sides that are the same length, the triangle is isosceles. Okay, so there's some vocab related to isosceles triangles. So let's talk about that. Here's an isosceles triangle. Here's the two congruent sides, right? The tick marks tell us that the sides are congruent. So these two congruent sides with the tick marks, those are called legs. So each isosceles triangle has two legs. The side that's the non-congruent side, the remaining side, is called the base. So we have two legs and a base. And then we also categorize the angles. So the top angle, this angle up here, this is called the vertex angle. And then the two angles that are touching the base, so this angle down here, and then this angle down here, those are called base angles because they're touching the base. Okay, so for sides, we have two legs and a base. For angles, we have one vertex angle and two base angles. All right, so just looking at this figure, you might be guessing that these two base angles look pretty much the same. And they're across from these two sides that are the same, so maybe it seems to make sense that they would be the same. And that's actually what the isosceles triangle theorem says. So the isosceles triangle theorem says that a triangle is isosceles if and only if base angles are congruent. So we can use this in two different ways because we have the if and only if. So first, if we know that two sides are congruent, so like this triangle has two congruent sides, we know the triangle is isosceles, therefore the base angles are congruent. So then we can conclude that there are two congruent angles. And they're the angles that are across from the congruent sides. So these would be our congruent angles. Those are the base angles. Okay, so two congruent sides means two congruent angles. We can also go the other way. So let's say you know that there are two congruent angles. Then we know that there must be two congruent sides. So we have two congruent angles here, then the sides that are across from them will also be congruent. Those will be the legs of the triangle. Okay, so if you put those two things together, an isosceles triangle is a triangle that either has two congruent sides or two congruent angles. And if you know that it has one of those things, then it has the other. Okay, so let's do some examples with isosceles triangles. Our first example here is going to have us find the measure of angle A. So we might notice right away that this is an isosceles triangle. We have two congruent sides. So that means that there are two congruent angles. That's the isosceles triangle theorem. So this angle is a base angle, it's 70. That means that this angle, which is the other base angle, is also 70. Okay, so we filled that in by the isosceles triangle theorem. Now to find angle A, we're just going to use triangle sum. 70 plus 70 is 140. We know all the angles together make 180, so we can do 180 take away 140, and we get 40 degrees left over. So angle A is equal to 40 degrees. And we used isosceles triangles and the triangle sum theorem to find that. Okay, let's try another one. We're going to find angle P. So we know that this triangle is isosceles because we have two congruent sides, right? Wow, my handwriting is super bad in this video. I'm sorry about that. Two congruent sides. So that means that there are two congruent angles as well. And they're the angles that are across from the congruent sides. So here's our congruent angles. Okay, so we know that these two angles are equal to each other. We know this angle is 114, and we know that all together they make 180. So let's use triangle sum. We can do 180, take away the angle that we have, 114. That leaves us with 66 degrees. So these two angles together make 66, and they're also the same, so we can just cut 66 in half. So we find that angle P is 33 degrees. And angle Q is also 33. We weren't asked to find that, but we can know that as well. So again, we used isosceles triangles to figure out that these two angles would be the same as each other, and then we used triangle sum to figure out what their number of degrees is. Okay, one more example. In this example, we're told that the perimeter of triangle MNO is 20 centimeters. So let's quickly remind ourselves what perimeter means. The perimeter is the distance around the outside of a shape, or in this case, the triangle. So if I go all the way around this triangle, I should get 20 centimeters. We want to find the length of MN, and we also want to find angle N. Okay, well, angle N is not that hard. We already have two of the angles, so we can just use triangle sum to find angle N. So 81 plus 81, that's 162. We know all the angles together make 180, so let's do 180, take away 162. And we get 18 degrees. So angle N is 18. And that was just triangle sum. We didn't need to use anything about isosceles triangles there. Isosceles triangles are going to come in when we're finding MN. So this triangle has two congruent angles, right? That means that it must have two congruent sides as well. That's the that's the isosceles triangle theorem. So we know that these sides are the same. Okay, now we know all the sides together make 20. One of the sides is 4, so we can use that to find our missing side. Let's do 20 centimeters, which is our total. Take away 4 centimeters, which is the side that we have, and we're left with 16 centimeters. So these two remaining sides together have to make 16 centimeters. We also know that they're equal to each other, so to find just one of them, we could do 16 centimeters, cut it in half, and we get 8 centimeters. So MN is 8 centimeters. All right, so that's isosceles triangles.